Hello everyone, my name is Deepkaran Singh and my student ID is S2242955533. So in this project, my aim is to explore and model a subset of the Redwine dataset to predict the alcohol content based on the chemical properties of the wine. So the basic overview of my project is I did data distribution and initial observation, transformation methods for key variables, model fitting procedures and comparative results, prediction outcome and model implications. So my original Redwine dataset contains 1599 observations and 6 variable from x1 to x5 plus wine quality. So the sample used 460 observation for the analysis. I identified distribution characteristics as X2 chlorides, X4 in pH and variability observed difference in range across prediction in which different features in the datasets have varied range of scales. For example, alcohol content and residual sugar have different values ranges. So this is my exploratory data analysis and scatter plots in which x1 versus y shows that values of x1 are concentrated near 0 indicating a right skewed distribution. In xq it is similar to x1 which is heavily right skewed. In x3 it was right skewed, values mostly packed towards the lower ranges. X4 was more symmetric distribution compared to others, slightly skewed but relatively normal in shape. X5 was right skewed again with the peak around 10 to 11. This is my exploratory data analysis for histogram plots. In X1 shows moderately linear and spread possible positive correlation. In X2 it was pairs relationship, very weak correlation. X4 was densely clustered, mid values were someone predictive potential, and X5 constantly spread, potential weak positive linear correlation. Relational for transformation. In this, the transformation helps to correct skew data, making distribution closer to normal, stabilize variance across predictors. Some predictors have varying level of spread. Transformation helps to stabilize this, ensuring that no variable disproportionality influence the model. Align variables to compare scale using min-max normalization. Detailed transformation method. X1, which was citric acid, square root transformation has been implemented. X2 chloride log transformation with constant X2. X4 negative, then squaring. In X5, which was alcohol, power transformation, where exponent was 0.5. Transformations of the response variable. So basically, I applied a mild power transformation to the wine quality score Y. This helps to align the response variable with the transform predictors. After making predictions, we reverse the transformation to bring results back to the original scale. After transformation, normalization applied to all the scale between 0 to 1 using min-max transformation. X1 distribution became more uniform. X2 maintains left skew even after transformation. X4 now appears more bell-shaped. X5 still slightly skewed. Y appears more bell-shaped, better suited for prediction. After transformation in histogram plot, x1, x2, x3, x5 were highly skewed distribution with concentration of values near to the lower end. X4 appears more normally distributed and x6 multimodal or discrete distribution. Data normalization. After transformation, we applied min-max normalization to scale all the variables between 0 to 1. The benefit of this is it improves comparability, enhances model stability, and helps the algorithm coverage more efficiently. Here are the comparative error metrics where the model WAM, WPM, and WPM and WOA, OWA, which was mine, which shows better result than the other three. These are the model weights and parameter summary where x1 shows all 0, x2 0.55747, x4 all 0, and x5 0.44253. Prediction outcome and reasonability. New input. We use input values 0.8, 0.63, 2.51 and 7.0 for the variables x1 citric acid, x2 chloride, x4 pH and x5 alcohol. Transform prediction. The model predicts a value of approximately 0.913 on the transformed scale. Final prediction. After reversing the transformation, the final predicted wine quality was 1 after rounding. Conditions for higher wine quality, lower chlorides. The model suggests that as chlorides decreases, wine quality improves. Optimal alcohol level, moderate alcohol content is positively associated with the better wine quality, supported by its higher weight in the model. pH X4 and citric acid X1. These variables, although transformed, have lower weights, indicating that their impact on wine quality is secondary or conditional as compared to chlorides and alcohol. Implications, limitations, and ethical consideration. The implications were model aids in understanding key factors affecting wine quality and can drive quality control and product adjustment. Limitation based on the sample, which was 460 observation, may not generalize broadly. Transformation and normalization may oversimplify complex interactions. Ethics and data privacy. Transparency in the model reporting and acknowledging limitations, ensuring that the data normalization and compliance with the data privacy standards. Thank you so much.